In this video we are talking about ISaveHandler, the interface you're implementing into a MonoBehaviour. So the MonoBehaviour has all the method needed to talk successfully to the Save system. You will see how the general workflow with the Save system is and how you are creating your persist-able MonoBehaviour scripts. So let's get started by creating a MonoBehaviour. We just simply name it player and open it up, and we see that a MonoBehaviour that are planned to be persistable needs to using Kobeltstuff comment and using Kobeltstuff Save system. Then we want to implement ISaveHandler, which indicates the MonoBehaviour behavior talks with the Save system. And to do so, we need some stuff. We have the stuff we needed to implement to be able to save this MonoBehaviour. It looks a lot, but we have a generator and most of the needed stuff is fast to implement. We have a dirty getter for the dirty flag, and we have 3 getters for the data identity. We have an object ID that I usually use the scene name, scene build index, something like that. The object ID is the whole container which gets loaded. As you can see it's container for all the active data, the live data. So all the data living in the scene, all the game objects like that, or all chunk data. You can use it as you see it fit. I will call it simply scene for the example, and the element ID is the file storing the data. And since we using this MonoBehaviour on the game object, we would in a proper project use an GUID, but for example we just name it game object, and the subkey is the identifier for the data stored in that file element ID. So you could have multiple MonoBehaviour data saved into this element ID, and we call this simply player for the example. After we have done this, we need some fields to be saved. Since we are deterministic, we want to have fields that using ISaveData, since ISaveData is that contract passed into the Save system. So we want to consider to use all the S-types or custom ISaveData in our MonoBehaviours. We can use it as runtime data as well, so we don't have to hold an int and convert it later into an S-type. We can just create an S-type and use it, like int sint health, and we, since this is in reference times, we use new sint, because sint an S-type in ISaveData is not null at any time. And then we can, you will have a public inventory, our custom ISaveData, and call it just inventory. We want to do it set new to, and we want to have public. We just do public. This doesn't matter. We can have public, private. Save system doesn't care about that. Just what you pass into it. So we do public like SS string. Display name equals new as a string. So now we have 3 fields to save, and our player can now implement these methods. We are going back to the editor. In the menu we have our Kobeltstuff, and just like the ISaveData generator, we have in generate SaveHandler for MonoBehaviours. So we can simply type our name of the class in and load the type, and we see it's finding all the fields, all the ISaveData fields. Normal fields would be marked red and not selectable. So, and the best thing, we have the global source game object. Since we have a player, MonoBehaviour, maybe we want to save the transform data, or just the position, or the game object name. That's the global data we are able to save. We want to save the complete transform, and we want to save the object name and all the 3 fields, and generate the code for it. And we see, just like the ISaveData generator, we get our code for the save and loading part. We see we have a save me method, just returns if we are not dirty. The setData method takes an ISaveData array, which is created by a build save array method, and we see we get a new asInt into the save array method. We get the transform and the all game object name, the global data, and then we have our STAB data. You could manually add or remove or as you need it. Then you even can do a new asInt, your custom field if needed. But to be able, the generator only works with S-types, since we want to have a deterministic workflow. You know, you want to persist something, use an ISaveData. And now we have the set30. We can use the is30, which is created with the save me part. Put it here, set value, and we have our setter. Our getter is done also, and we can do the load path. We have the switch part. We add it here, and we can see we have, like the ISaveData, our switch that decides which loader is used. We load the file version, and we throw an exception. If something gets wrong, you can remove it like you need it. And we have our loader. Just put it here, and we see we have a loader for 1. We have an index, expected length, we have everything needed to load the data, and this is all we need. Therefore, we can just close the region, and you see that you have a better look at the class. It's not cluttered, and the only thing we have to type now by hand is the SaveManager.gather SaveData plus equals SaveMe, and we have SaveManager on data loaded plus equals loadMe. Note not loadMe version 1 because we want to have loadMe and the decision making over the switch which version we are loading. And for good measure, on destroy or just unsubscribed. So this all there is to it. And now you can save your MonoBehaviour, and you can use it like a normal MonoBehaviour. You can start by adding fields like this, and just for example, and those fields are unaffected by the persistence. You can now deal with the MonoBehaviour like any other runtime class, work directly on the S types. So, for example, you can do a private int test, so you can see. So, and in start we could test equals health. Note all S-type wrappers like sint, sfloat, strings comes with a implicit operator, so this is totally fine. The other way around, you have to write dot value equals test. So if you are setting or adding to the value, use the value. So since we are in reference type, this isn't the best, because then this isn't a good way to deal with it if we would have it like this. So we wanna explicit work on value that way, but reading the value gets easy. Yeah, and this is all there is to it. Now you can save your MonoBehaviours on that triggers. Like in part 1 we are showing the triggers. I hope we see us in the next part. I will explain how to refactor a class and to proper migrate old data to the new data.